So continuing with this assignment, we'll look at part 2 now, which is the other front casing part. So looking at this again, we could approach it in a couple of different ways. I guess we could probably do it as a big kind of rectangular lump and then shell this out because it has a wall thickness that's consistent. And then we could do some extrusions to chop out these little notches that are shown at the sides. We also have a circular hole and then some smaller circular holes that are on the specified PCD, which is up here, PCD 66, repeat 6. So that's going to be a radial array. And we've got some little chamfers at the corners here. And if we're using the shell, although I suspect we might be okay with that, the shell not kind of cutting into there, or not showing up that chamfer on the inside if we did the chamfer first. Just for the sake of safety, we'll leave the chamfer until after we've done the shell so that we don't run the risk of the shell making a little chamfer on the inside that mirrors that when we don't want it to. Otherwise, pretty straightforward component. It's just really going to be an extrusion to begin with of a big rectangle. But to save us a little bit of time, again, rather than doing a lot of things twice, because this is a symmetrical feature, we could probably actually just model one half of it. And then we could duplicate that across the way, or at least maybe model the whole thing and then just mirror the circular feature that we make across the center. So just because sorting out the bit in the middle that would have a gap might be a bit of a hassle, I think my inclination is probably just to model it as a whole piece rather than modeling one half at a time. But you could go about it that way. It doesn't really make much difference. So let's get on with it. Its overall size is 186 by 96 and it's 13 deep. So let's create a new part file. And again, pick our work plane that's going to orientate it correctly. And I would probably want to use, again, which one here? Yeah, 3. Try again, click on the wrong one. 2-point center rectangle. So we said 186, 96, 13. So 186, 96. And we'll extrude that. 13. Back the way. Now, the next thing that we need to do at this stage probably is just to shell it. So we'll shell it from the back and we're going to give it a wall thickness of 3 as it specifies here. Shell 3 millimeters. And having done that, we could now add our chamfers to the corners here, and they are all 3 by 45, so that just basically means a normal 3mm chamfer. So we'll go around and find our chamfer tool, 3, we'll go select these. There we go. So that's that part done. Next thing I'm going to do is deal with these little notches at the sides here. So it looks like they only go down to the kind of depth of the flat part of this here. You can see them cut out there. And the width of those, let's see, are 10 millimeters. So quite easy to do that. We could do it in a couple of ways. We could sketch on the face or we could sketch on the side. It doesn't really make a huge difference, so I'm just going to do it on the side. And in terms of position, it appears that they are centered because it's on the center line here lines up the middle of it. So we'll just assume that they're in the middle. Likewise with these ones, they appear to be centered. So we'll draw a rectangle in here. Make sure it's 10 millimeters by 10. And make sure I've got in the right position because I think I might, started it on the wrong edge, so that was silly. Go back. I started on the back edge. So this side this time, 10 by 10. And it's just important that we snap it to that back edge because we want it to cut out to that side, not over here. We can then use our constraint tool just to position that in the center. And having done that, we can extrude it, cut, and 13 is fine. It'll just make sure it cuts through there. And the same thing at the top here. So start sketch on here, rectangle, 10 by 10. And use our horizontal constraint here. Oh, that's curious. Oh, I think I know why that is. It may be. No, that's not. Let's just try that. I think I was actually trying to accidentally constrain this back edge here rather than the center of this. So I'll find the center point at this side. That's probably why it wouldn't let me. Right. So we want to get that bit. Try again. This one here and that bit. Okay, that's it. So that is now constrained, and we can finish our sketch. Extrude, cut, or should I say subtract. And we've got those two, and if we make our origin planes visible, we will be able to use those when we do our mirror here. So we'll just mirror that feature there. Across that plane, and we will mirror that feature across that plane. So that's them all done. We're going to leave that plane visible because we'll need it when we create the circular feature, the circular hole feature, but we don't need this one visible, so we'll make it hidden again. So going back to this, we have a circle which appears to be basically centered, and it's positioned 50 millimeters from the center of the object. It has a diameter of 60, so we'll do the hole first, the big hole. So we'll sketch our surface here, 50, and dimension the center of that to the center. We've got 50 as well. We're happy. Yep, that's where it needs to be. 48 should be kind of incidental because that'll just be halfway. But we could always constrain it by adding that dimension just to make sure we can't accidentally nudge it into the wrong place. Extrude, again, extrude cut, or extrude subtract. And then we'll do another sketch here for the circular hole, and it is on a PCD of 66. So we will start by doing a construction line, the circle, to give us a kind of a center point. Oh, that's a pain. Hold on, we want to just get the center point off of this circle here. So I'll just project geometry from it. And now we should be able to do the circle. That was going to be diameter of 66 because that's the PCD for the holes. So PCD basically just tells us the center point, or it gives us the diameter of a circle, which transcribes the centers of features that are usually arranged in a circle, like holes that are arranged around a center in a circular kind of pattern. I'll just double check that. That looks a wee bit off to me. It looks like that's bigger than it should be. I'm just going to double check that I haven't made a silly mistake. I think I might have when I did that extrusion here. Yeah, I did a silly mistake there. So that should have been, that hole in the middle should have been 60. So I'm just going to finish the sketch and I'll go back and fix that. That's why it's always good to just, keep an eye out if something doesn't look right. Probably isn't, so that means you need to go back and sort it out. And now when we look at that, the relationship looks a bit better. So diameter 3 hole repeats 6 times. So we'll open that sketch back up. And we want that first circle to be really dead center at the top here. So if we hover over the middle, we'll get that trace line that tells us we're aligned. And we want that to be centered on that outer circle, 3 millimeters. And I'm going to extrude that through to cut. So we've got one of these, and we should now be able to array that feature around the outside. So if we go up to here, use our what we call a radial array, try and grab that guy there, use that circle as a rotation axis, and it's fortuitously guessed that I need 6, so we can just make that happen. Now all we need to do is mirror this and this feature, and then mirror across this plane, and that would appear to be that part completely done. Let's have just a double check, make sure there's nothing else that we need to do. And no, that's it. So as always, it'd be a good idea at this stage to use your measure tool. Just double check the key dimensions, look over it, make sure that nothing silly has happened, that you've not made a silly mistake somewhere. But that's all good. So we could call that done and move on to the next part.